Today, we will talk about 5 ways artificial intelligence is revolutionizing environmental monitoring. From city navigation and ride shares to energy management, artificial intelligence is entering everyday life. Environmental sustainability and commercial goals can benefit from artificial intelligence. A POC and Microsoft study estimates that artificial intelligence in environmental technology might be valued $5.2 trillion USD by 2030, 4.4% more than business as usual. Before we start with our number 5 spot, give a thumbs up to this video and subscribe to get the latest updates. Let's begin. Number 5. Artificial prediction and data analysis. Artificial intelligence is redefining environmental monitoring by enabling new methods of ecosystem analysis and prediction. Traditional data analysis techniques are finding it difficult to keep up with the exponential expansion of data being created by satellites, sensors, drones, and other monitoring equipment. However, artificial intelligence provides strong tools to sort through enormous datasets, derive valuable insights, and forecast environmental trends with previously unheard-of accuracy. The ability of artificial intelligence to identify trends and abnormalities in environmental factors like air and water quality and deforestation is a crucial application of artificial intelligence in data analysis. Artificial intelligence can spot tiny trends that human observers would miss by using machine learning algorithms, which helps us comprehend the intricate dynamics of our surroundings. For instance, using historical data on air quality, artificial intelligence systems can locate pollution hotspots and forecast future trends based on variables like traffic, weather, and industrial activity. Furthermore, by analyzing data from distant sensors and imaging devices, artificial intelligence makes it possible to monitor environmental conditions in real time. Artificial intelligence systems can identify changes in land use, vegetation cover, and urban growth over time by using high-resolution photographs of the Earth's surface that are captured by satellites fitted with sophisticated sensors. Similar to this, drones fitted with cameras and environmental sensors can gather information from difficult-to-reach locations like wetlands, mountains, and forests, offering important new perspectives on the biodiversity and health of ecosystems. Using predictive modeling approaches, artificial intelligence is able to predict future environmental conditions in addition to studying historical data and real-time observations. Machine learning models can be trained on vast datasets of environmental factors and their related results, enabling artificial intelligence to forecast future trends and possible risks with high accuracy. Artificial intelligence-driven early warning systems, for instance, are able to predict the likelihood of natural disasters like hurricanes, wildfires, and floods based on variables like humidity, temperature, and atmospheric pressure. This predictive capability enables authorities to take preventative action to safeguard people and property. Artificial intelligence is transforming environmental monitoring by improving our capacity to evaluate enormous volumes of data, identify patterns and anomalies, and forecast future trends with previously unheard accuracy. Our environment may be preserved for future generations by using machine learning algorithms and sophisticated data analytics techniques, which provide us with important insights into the intricate dynamics of our ecosystems and help us make wise decisions. Number 4. Imaging and remote sensing. Artificial intelligence is revolutionizing environmental monitoring by merging image and remote sensing technology. Remote sensing uses sensors on satellites, airplanes, drones, and other vehicles to collect data. By analyzing data from these sources, artificial intelligence systems can reveal environmental factors including vegetation health, water quality, and land cover. Satellite imagery is a prominent remote sensing data source for environmental monitoring. High-resolution Earth images from satellites with optical sensors, radar systems, and other imaging equipment can be used by artificial intelligence algorithms to track land usage, vegetation cover, and urban growth. Satellite photographs can be processed by artificial intelligence-powered image classification algorithms to identify woods, croplands, and cities. This helps manage natural resources and plan land usage. Forests, marshes, and hills are also being monitored by drones with cameras and sensors. Artificial intelligence systems can monitor animals, vegetation, and environmental challenges, including habitat loss, erosion, and deforestation using drone footage. Artificial intelligence-based object detection systems can recognize trees in drone photos and follow forest cover changes, giving conservation data. In addition to static photos, artificial intelligence can understand remote sensing sensor data on weather, ocean currents, and atmospheric composition. Weather satellite data can help artificial intelligence systems track and predict hurricanes and tornadoes. Likewise, artificial intelligence-driven oceanographic sensors can measure salinity, acidity, and sea surface temperature, delivering vital marine ecosystem and climate change data. Number 3. Prompt warning systems. Early warning systems for natural disasters and other environmental risks are being developed using artificial intelligence, transforming environmental monitoring. Early warning systems provide timely and accurate information to emergency responders, government agencies, and the public, reducing the effect of hurricanes, wildfires, floods, and earthquakes. Artificial intelligence can predict natural disasters by analyzing historical data and real-time observations in early warning systems. Artificial intelligence algorithms can predict hurricanes, wildfires, and floods by training machine learning models on vast datasets of environmental variables and their results. Artificial intelligence-powered weather forecasting models can assess atmospheric pressure, temperature, humidity, and wind patterns to predict hurricane paths and intensities days in advance, allowing authorities to give warnings and conduct evacuation preparations. Artificial intelligence can improve early warning systems by evaluating environmental data, social media, cell phone data, and other real-time sources. Artificial intelligence systems can identify natural catastrophe trends and public attitude by analyzing social media, news, and other online material. Artificial intelligence-powered early warning systems can alert impacted communities to approaching disasters like wildfires, floods, and earthquakes by monitoring social media and other online channels. Artificial intelligence integrates data from satellites, sensors, drones, and social media into a single early warning system. Artificial intelligence-powered early warning systems can deliver more accurate and comprehensive disaster warnings, allowing authorities to take preventive measures to protect lives and property. Artificial intelligence systems can use weather satellites, river gauges, and soil moisture sensors to anticipate floods and warn at-risk communities. Artificial intelligence is changing environmental monitoring by improving our ability to forecast natural catastrophes and other environmental dangers and give emergency responders and the public with fast and accurate information. Number 2. Precision farming. Artificial intelligence-enabled precision farming is changing agriculture by optimizing resource consumption, crop yields, and environmental effect. Smart farming, or precision agriculture, uses sensors, drones, GPS, and artificial intelligence algorithms to monitor and control crop output more efficiently. Precision agriculture uses artificial intelligence to optimize irrigation by analyzing soil sensor, weather station, and satellite imaging data. Artificial intelligence algorithms monitor soil moisture, temperature, and other environmental variables in real time to calculate the best irrigation timing and volume to maximize crop yields while minimizing water and nutrient runoff. Artificial intelligence-powered irrigation systems may change watering schedules based on real-time weather forecasts and soil moisture data to ensure crops get enough water at the proper moment. Artificial intelligence also allows predictive models to anticipate crop yields and identify pests, diseases, and nutritional deficits. From previous crop performance, weather, and soil data, artificial intelligence systems can estimate future yields and offer productivity-boosting measures. Artificial intelligence-powered agricultural monitoring systems may analyze satellite imagery to detect crop stress, such as nutrient deficits or pest infestations, and inform farmers to take action before damage occurs. Artificial intelligence optimizes irrigation, pest management, and precision planting to maximize seed placement accuracy and minimize seed waste. Artificial intelligence algorithms develop planting maps that optimize seed spacing and placement for yield by assessing soil composition, topography, and historical crop performance. Artificial intelligence-powered planting devices can modify seed spacing and depth in real time based on soil and crop conditions to ensure field-wide germination and plant growth. Artificial intelligence also helps create autonomous farming equipment that plants, sprays, and harvests without human intervention. Autonomous agricultural systems use sensors, cameras, GPS, and artificial intelligence algorithms to navigate fields, recognize crops and weeds, and conduct precision tasks with unparalleled accuracy and efficiency. Number 1. Monitoring and preserving ecosystems. Artificial intelligence is transforming ecosystem monitoring and conservation by analyzing large-scale environmental data and developing predictive models for biodiversity conservation, habitat restoration, and sustainable resource management. Artificial intelligence can assess species distribution data and track biodiversity changes in ecosystem monitoring. Artificial intelligence systems can discover conservation hotspots and species population trends by evaluating satellite photos, camera traps, and auditory sensors. Artificial intelligence-powered species distribution models can predict endangered species distribution and prioritize conservation efforts based on environmental variables like temperature, precipitation, and habitat type. By evaluating habitat fragmentation, deforestation, and land degradation data, artificial intelligence can monitor ecosystem health and resilience. Artificial intelligence algorithms can detect land cover and land use changes and assess human impacts on ecosystems by analyzing satellite pictures and other remote sensing data. Artificial intelligence-powered deforestation detection systems can scan satellite photos to identify forest loss and degradation and alert authorities to protect remaining forests and wildlife hotspots. Artificial intelligence helps construct conservation planning and management decision support tools and monitor ecosystem health. Artificial intelligence algorithms can help policymakers and conservationists prioritize conservation areas, plan habitat restoration projects, habitat quality, and human activities to prioritize conservation efforts and allocate resources. Intelligent monitoring methods like citizen science and crowdsourced data collection are possible with artificial intelligence. Artificial intelligence-powered citizen science programs may collect and analyze massive amounts of environmental data at little cost and reveal local biodiversity and ecosystem dynamics. Users can record wildlife, flora, and environmental conditions in their area using artificial intelligence-powered mobile apps and contribute data to scientific study on climate change, invasive species, and habitat loss. Overall, artificial intelligence is transforming ecosystem monitoring and conservation by analyzing large-scale environmental data, developing prediction models for biodiversity conservation, and implementing innovative monitoring methods like citizen science. This is it for today. If you liked the video, let us know in the comments. You can also share this video to show your support. Goodbye.